Hello, folks. Welcome back to Management 5804 Leadership and Technology Based Organizations. I'm Dr. David Townsend, and this will be Lecture 3. And in this lecture, we're going to spend a few minutes talking about AI powered strategic decision making and technology strategy. So, the goal here is to link together some of the material we've covered here in the intro units to set a foundation for our discussions for the rest of the semester. The broad goal here is to really identify some critical challenges that strategists face when dealing with some of the new opportunities, but also the difficulties that AI is going to present to developing technology strategy in organizations. So, as we talked about before, and we read in some of our readings earlier in the semester, technology strategy itself is kind of a special subset of strategic decision making within organizations, and it deals with this integrative set of choices about how to utilize or deploy new technologies to pursue essentially what are the core goals of strategy and strategic decision making overall, right? So, this goal of producing superior financial returns over the long run, or what other people might call sustainable competitive advantages, right? So, advantages that we have in a marketplace that allow us or reflect the ability that the firm has to outcompete other firms, right? And the ability to protect that. And so, new technologies clearly are opening up some of these new choices. And AI in particular is going to be a powerful set of tools, or provides a powerful set of tools for organizations to deploy that oftentimes, or to pursue opportunities that oftentimes the firm doesn't necessarily have the means to pursue, right? And so, in particular, right, a lot of technologies are opening up new choices for firms, so creating new sources of value, targeting customer needs that you couldn't have met in the past. And again, we'll think about multiple different types of use cases for AI where it's allowing us to really identify critical, almost sometimes latent customer needs that companies weren't even necessarily aware of, and to deploy new products, new services, new platforms to provide unique solutions to those needs and wants. Also, AI and new technologies allow us to lower cost in dramatic ways, right? And so sometimes this sort of digital worker model we'll talk about later on the semester with Blue Prism provides the means for firms to reduce costs. So you have algorithms and smart programs, smart software systems that allow us to, at least in a very limited sense, sometimes augment or replace certain types of human workers, but it also enhance the productivity of our current workforce. Also, AI is enabling the emergence of new strategic positions, and we'll talk about the formation of these digital ecosystems and the ability for firms to kind of stake out new ground and pursue new markets that they've not traditionally been able to pursue before because they lack the means to do so. And so within that, right, there's new types of competitive advantages that are emerging. And so again, these are the core goals of technology strategy, and clearly AI is going to provide a critical set of tools for firms to utilize in order to pursue and accomplish these aims. So in the reading, we talked about decision making, the kind of history of decision making, and it goes through kind of the long history, if you will, of how over the last few centuries, really since the Enlightenment era here in the kind of global North and in European context, how firms or individuals had developed new theories, new ideas about probabilities and indeterminism to come up with ways to make better strategic choices. And so, again, this was part of this, the cultural pursuit of humanity in order to be able to quantify the unknown, quantify the things that we didn't know about or couldn't expect or couldn't predict. And, again, within that, there was this notion that we'd be able to move towards perfect rationalism or, perfect certainty about the circumstances in which we operated and about the futures in which we were making decisions. But I think especially over the last generation or so, there's been a growing awareness that there are significant constraints, and sometimes those are contextual, right? Just the information itself doesn't exist in particular environments, or psychological. And certainly those of you who've ever read things, within the behavioral economics literature know about all the different psychological biases that we have. And the reading highlights some of these important findings that both economists and psychologists and others have identified over the years that point to specific limitations that we have as individuals in our ability to make optimal choices. And in the middle of that is really the problem that we've talked about of just complexity, right? So complex circumstances, time constraints, and then inadequate mental computational power, right? Keeps us in the state of bounded rationality. And so we've talked about this notion of framing strategies, right? And we've defined framing in two specific ways. We talk about it, one, just in the sense of limiting, right, the amount of information that we bring in. So literally a frame would be just us taking a snapshot of a limited set of information that we're going to pay attention to. And then the second dimension of framing that we talked about is then against that kind of limited set of information we're going to consider, we overlay our own interpretation of it, right? And so we've used this kind of picture frame metaphor a couple times. You've seen it in some of the graphs or some of the pictures in the slides. And the entire point here is that this notion of bounded rationality or bounded decision making is really how humans have had to deal with the problems of complexity. And again, we've defined complexity with this DINE model, this diagnostic, interactive, non-predictable, exponential change model. And really the diagnostic part is really the first layer where, again, we just can't consider all the relevant information that we need to consider. And so, again, against this kind of backdrop of long history, there's been this pursuit of better tools that enable us to make more and more effective decisions, right? And this is kind of one of the critical parts of how, again, AI is going to intersect is really a new generation of, powerful tools to augment our decision-making opportunity or abilities as decision makers. And the real challenge, really, again, for any type of strategic choice is the sheer complexity of options that we're facing. And so those of you who've ever worked in kind of DevOps or any context where you've had to build decision trees, right? And you've had to kind of map out how an individual might respond to different bits of information that are passed along, or they might kind of scan through an information environment. As you kind of move down layers from kind of rows of dots here, and we call these kind of points or points of contingency, right? And so each dot represents a different decision node where an agent or an actor or an individual has the opportunity to pick a different path. And you can see as you kind of move down these rows of dots, the number of available choices along those pathways can grow exponentially. And again, this is one of the major problems of decision making. Again, so if you think about kind of the first dot at the top and you move to the second row, we call it sort of first order uncertainties, right? So this sort of the notion of which of those 5 paths would you pick, which one is going to yield the optimal choices. And potentially maybe these are just different product opportunities that the firm is considering, right? So different design choices about how they might go about building a particular product to appeal to different customer segments. But as they make those choices, they get locked down on a particular path, which sometimes opens up a new array of choices, but also can lead to dead ends, right? So as we consider, the first set of 5 choices, we move to the second row, right, or to the second order contingencies here, you see some of those choices dead end, right? And so you may get to a particular spot where it turns out the choice doesn't lead anywhere further. You run into an insurmountable technological roadblock. The technology just can't, the laws of physics prevent you from, engineering your product with a particular electrical charge, because the battery capacity isn't strong enough, or because you can't hold enough electricity, or because the power needs are too great given the size of the product itself, or simply, the technology doesn't exist yet and hasn't been invented, and there's no means, no pathway to get there in order to do it. And so again, as the decision makers are anticipating all these different potential contingencies, and you move from layer to layer to layer, it becomes nearly impossible to really determine what are going to be the optimal pathways or the optimal choices. And so again, part of this problem of complexity, or this DINE model, is figuring out which paths to take, which paths are going to lead us to the end goals that we think we have given our set of strategic choices. And so within that, there's the article talks about this kind of gut versus brain dichotomy that a lot of people think about, right? And so historically, this idea that humans are uniquely endowed in order to make decisions in complex environments was very much a powerfully central framework in how people thought about making decisions, and how they thought about the use of different tools to help them make decisions. And again, this notion of using intuition or holistic thinking in complex environments was largely because human actors can integrate lots of information much more than computers can. So computers, if you set up a programming, or you set up kind of a program or an algorithm basically, and you're setting up kind of a linear sequence of decisions, or maybe a set of if-then clauses in your programming in order to determine how you'd kind of map through that, or you'd navigate through that complex decision environment, you would have to kind of anticipate all of those things up front. And so computers obviously can compute probabilities and compute data incredibly quickly, but the ability to integrate very diverse streams of data in order to make decisions has largely been the purview of human actors, right? So we can anticipate a lot of those contingencies, right? So in the last slide, we talked about kind of the different rows of dots there. And humans are quite good, at sort of thinking through those different options and figuring out, especially when those dots represent choices that other actors may make. And so, we may think a product is perfect, but our customers think otherwise. And, and have different views or different needs or wants that are going to drive their decision making. Well, humans are pretty good, overall, maybe as a species, not necessarily as individual actors, in order anticipating some of those contingencies. And we're also, clearly much better at determining values and ethics in decisions, right? Because some of those pathways may represent non-viable choices or unethical choices. And it's not that all humans, necessarily ignore or decide not to pursue choices that are unethical. I mean, clearly we know that's not true. But again, humans are quite good at evaluating different pathways if the questions really become, is this the right path in an ethical sense for us to take? And then humans also, have largely been seen as, having the creativity or the imagination to envision pathways that others haven't necessarily come up with. And so we laud appropriately in many ways the innovators and entrepreneurs and others who were able to imagine new alternatives, new pathways that others haven't thought about, new ways to configure products and services that haven't been, necessarily conceived of by others. But the question for us is really, and again, we say, sort of we prefer the gut or holistic thinking in these situations because the brain is just a wonderful tool to integrate lots of diverse streams of information. And so what we think really is something emerging out of our subconscious, our intuition, is our brain integrating lots of different data inputs into some kind of systematic pattern that we think we're seeing. And so the question then becomes, right, kind of jumped ahead of myself a second ago, the question becomes, what if those kind of choices, though, are computable, right? What if across all these different complex decision trees, there are ways that we can build algorithms to augment human choice to make us even more capable of anticipating a lot of these different contingencies and these problems that we face when making decisions. And I love the way the article really summarizes a lot of the history of decision making. And it notes that this gut-brain dichotomy is largely false, right? So most decision makers are going to ignore good information when you can get it, but it doesn't always mean that the data that you need are going to be there, right? And so our intellect can inform both our intuition and our analysis, and that a lot of this process of augmentation is really improving the role of our own intelligence and instincts in making decisions in a holistic manner, right? And so part of what we're going to really try to tackle this semester, and I'll show you, with our two major frameworks that look at the technology adoption lifecycle and this sort of S-curve logic of when our intuition often fails us as strategic decision makers, right? And so when we typically think that something's going to happen, when there are systematic reasons as to why it's likely not going to happen, probabilities would say it won't happen at these different stages. And so what we want to do is basically improve our intuition, our understanding of how to formulate technology strategy, and then consider how different AI tools may allow us to, to continue to augment or enhance our abilities to make effective decisions at these different stages. So not only do we want to kind of transcend this gut versus brain, right, this sort of intuition versus rationality, false dichotomy, but we want to think about how we can use tools effectively and incorporate those within our intuition to make much more effective strategic decisions. And so the question then, relative to that is this notion of AI and strategic decision making. And so there's an awful lot of things starting to be published to think about, can AI formulate strategy? And as we'll see, of course, right? But a lot of it is going to involve the integration with human actors. And so the one article that talks about kind of AI is ready for business, and so this is the report that just came out. That's one of our readings for this week. As you can see, there's an awful lot of data demonstrating, that AI is starting to rapidly diffuse within lots of organizations, and it's starting to become important for strategic decision making. But a lot of people still have let's say, a incomplete understanding of the role of AI, and a lot of people think back to this, relatively famous worldwide event. So if you know the picture here, this is Gary Kasparov in 1997 playing against the IBM Deep Blue system, and this is the first time, right? So this is the game where a computer beat the chess grandmaster. So Kasparov was the world champion at this point. And this is the first time a programmed chess engine was able to beat a human grandmaster. And so, again, this was sort of seen as this watershed moment for AI, and a lot of people kind of lauded the IBM team for their successful victory over Kasparov. Kasparov, admitted later that he was a pretty sore loser, and he kind of stormed out of the event after he lost. He said, not only was he a sore loser, and he'd rarely ever lost in his entire career, but this is the first time he'd ever lost in an entire head-to-head event where he lost multiple rounds. But the IBM team was also quite clear, and most of the informed commentators were quite clear that this was not an example of AI actually beating a human actor at chess. And so really what happened behind the scenes is that the IBM team had been working on this Deep Blue system for a long, long time. And there was millions and millions and millions of lines of code. And a lot of it was trying to anticipate all the different contingent moves that Kasparov would make. And they also had hired multiple other grandmasters who, were ranked just below Kasparov to work with him behind the scenes during the event. And so they updated the code, so to speak, during, breaks or between the games to actually anticipate how Kasparov was going to play his matches. And again, he was also largely convinced that there was some shenanigans happening behind the scenes and maybe even some cheating. There's never been any proof that there was cheating, but certainly, the IBM team and others noted that this was an incredible engineering feat, and it was an incredible advance for, the software system that they developed, but it wasn't an example of artificial intelligence beating a human actor, right? It was lacking a few things. But then, a few decades later, there's been a major change, and so those of you who know the game Go, and you recognize this event. So this happened, in 2017, right? So again, this is 20 years later after the Deep Blue Kasparov match. So this is Lee Sedol playing against the Google DeepMind. So DeepMind is an AI company that's housed in London, purchased by Google, and they build a bunch of these engines using some particular types of algorithms we'll talk about here in just a second. And they're playing against the world champion Go. And so this is Lee Sedol, is a Korean player. And so what you see here on the left-hand side, I want you to notice a couple things here. Is you see the Go board, and you see the human putting the board, or put the piece on the board, right, this white piece. But I want you to look up in the right-hand corner. I know the picture's a little fuzzy, but watch Lee Sedol's face, right? Because when he puts this piece down, watch his mouth fall open, right? This is the 37th move in this game. And the game of Go, just the way that it's set up, is infinitely more difficult than chess because there's actually more possible moves that you can make in the game than there are atoms in the universe, right? And so when you think about and trying to anticipate all of those different contingencies, and so we saw that in a decision tree, all those little dots were contingencies. Well, if you were trying to program this game and you were trying to program it to be able to beat a human actor, the problem is that it's basically an unclosed, there's no computational closure because there's almost an infinite number of moves you can make given the size of the board and given the rules of the game, right? So this piece that's put down on the board here and why his mouth falls open is because this move had never been done in 1,000 years of playing this game, right? It defied every intuition that humans had about how you play the game of Go, right? And so again, this is in this game. This is a move that's made and his mouth falls open because no one would ever play this move, right? This is not something you would ever do. And then based on this move, 37 moves later, right, the Deep Mind system beats the world champion, right, and was able to kind of pull the pieces together off of this completely astounding, paradigm-breaking rule or move. And the question really then becomes, right, is this an example of AI, or is this an example of computers matching or surpassing human intuition in terms of making decisions? Because this was not something that the developers of the game programmed into it, right? This is something that the algorithm had developed through and again we'll talk about kind of the general structure of some of the algorithms that Deep Mind team is using here. But again, this is one of those things where just an astounding kind of change because it defies all of what our intuitions are about how you make effective decisions. And what's really interesting about this is a human grandmaster, right? So a chess master, when they're looking at how they make decisions, they're able to anticipate hundreds of moves. And so part of what makes Garry Kasparov such an incredible chess player is because, he makes a particular move. So he might move the rook, from, one stage, make the kind of L-shaped move. Those of you who know how to play chess, I want to embarrass myself by telling you a particular chess move. But if you got the rook and you move it to this L-shaped, based on the rules, Kasparov and other grandmasters can think about hundreds of different contingencies built off of the different moves that they make. And that's part of what makes them grandmasters, right? They can anticipate lots of different patterns as they go. And the state-of-the-art chess engines that are out there on the market now can each time you make a move, they can estimate over 10 million different possible contingencies off of that move. And so they can anticipate lots of different consequences of any one decision within within a chess game. Now, AlphaZero was the system that DeepMind built after they built the AlphaGo system that you saw on the previous slide. And AlphaZero is now the world champion in Go. And when it makes decisions, so to speak, to play different moves in a Go game, it's only anticipating tens of thousands of moves, not tens of millions, but not hundreds either, right? So how is this algorithm able to collapse the decision problem down to a far fewer possibility spaces versus the state-of-the-art chess engines, but still surpass, by orders of magnitude human grandmasters, right? So this is what's critical within this, is none of these things are actually programmed into the system. And so AlphaGo Zero, or AlphaZero, again, is the world champion, was never programmed with any of these rules built into the system, right? So none of these things were human artifacts that were designed by programmers or developers at DeepMind. So they taught the system some basic rules of the game, and then basically by playing against the other algorithms, obviously can play very, very quickly. Within 36 hours, AlphaGo Zero reached the level of AlphaGo, right, who had basically beat the champion Lee Sedol. Here it says 2016. But you see, again, this again, just a day and a half, the system with minimal programming is able to develop, a strategy to do it. And then within 72 hours, it's able to beat the system, right? And then 40 days later, AlphaGo Zero surpasses every previous version and becomes the best Go player in the world, right? So think about that. This is a game that humans have been playing for more than a millennia. Again, there's more possible moves than there are atoms in the universe when you're playing it. And you have a system with minimal programming that's able to basically be the world champion in just slightly over a month by, clearly playing many different games, millions upon millions of games against other algorithms, but it's learning through this process. So what's happening behind the scenes? And this is this notion of generative adversarial networks, right, or these generative or genetic algorithms. And this is, again, where there's an awful lot of misunderstanding about what's critically different about the AI right now. And so you have these algorithms that are being built, and generative algorithms essentially are algorithms that are generating new possible combinations. And so if you're thinking about a product design, it may tweak different features of a product or configurations of a product, and it's able to do this rapidly. So it's able to iterate kind of design choices very rapidly. And then, the adversarial part is it's actually then clashing that against some kind of discriminator function. And so this is, again, kind of what a standard would be. Here's the game, here's the person, the competition you're playing against, and let me generate possible moves. And then from that, the algorithm is learning by iterating. So it kind of figures out optimal strategies by clashing possible, alternatives or alternative configurations against some kind of a filter, right? And then it gets, the feedback, and so it's able to fine tune the algorithm based on the performance, based on how did the choice lead to anything, effective, or did it collapse? And ultimately, this is basically the same type of an evolutionary process that we've seen in biology, where you have genetic variation, you have genes that are varying based on the underlying configuration of DNA, and that's clashed against whether or not that enhances the selective or the selection fitness of the organism. And so if the organism has a higher rate of survival based on those changes, then you see this this continuous improvement. But clearly, now that this has been built within these systems, these systems are able to do it incredibly fast, right? And so again, they're able to occupy, or at least try, alternatives that most of the time wouldn't be considered, and they're able to do it very quickly in order to determine whether or not you can get to superior configuration. So you can see now decision trees, right? If we're trying to design, here maybe like a game, an AI system that can play poker against humans, and so it's another game, where it's difficult sometimes because of just the sheer configuration of different possibilities. You can design these types of algorithms in order to beat. So you can even design them to bluff. You can design them, to operate in a way that they can optimize strategies to beat human players. And again, there's lots of these strategies, or a lot of these engines that are out there that are quite effective at at beating human players. But that's not, again, these are incredible examples within the game world. And for those of you who worked in that space, that games are a great way to do lots of training, given kind of you're in a digital ecosystem. But there are other companies that are incorporating this specifically within the company itself. And so there's a great company spinning out of Johns Hopkins University called In Silico Medicine. And In Silico Medicine is kind of a deep learning AI company that works in the pharma space. And what they're doing is they're actually coming up with unique possibilities here for different drug candidates. And so they've built a entire AI system here where it works along with the human actors and scientists and other people within the company in order to come up with different candidates. And there's been some real press I'll put in the module for this week. So it just happened a couple of days ago where the company published some results where they actually came up with a brand new therapeutic that now as they're doing some testing. This is something an AI system came up with completely on its own, and they're finding that it actually has some clear advantages or clear efficacy to be a promising new drug candidate, and for the pharmaceutical industry. And again, it's something AI came up with completely. And why, again, this is a similar type of problem is you can think about, well, there's 10 to the 3 power here of different diseases, right? And 10 to the 9 power of different, molecules, but there's about 10 to the 30 power in terms of possibilities of different drug candidates. And so it's a massive possibility space of different ways that you could design different therapeutics, different drugs in order to treat incredibly difficult or challenging diseases. And so again, it's a problem that these AI, these deep learning so the GANs, generative adversarial networks or genetic algorithms, these GANs are quite effective at dealing with these types of problems. And so you can see here from the structure of the way that they have it set up that you can use these things, in a way that, augments or creates, new imagined possible therapeutics that humans might not necessarily have the capacity, given our current state of knowledge, to come up with on our own. And so again, just like that Go piece being put somewhere where it defies 1,000 years of convention within the game of Go, these systems now have the possibility of coming up with similar types of breakthrough, recommended therapeutics, for new drugs. And so they built this entire system up, even getting to the point at the end where they can, predict what's likely to get through clinical trials based on data. And so again, it costs now somewhere close to $2.6 billion to get a drug through, a pharma pipeline in order to get it into the hands of patients. And so it's incredibly expensive. And, we've barely, given our current practices, no matter, have these kind of amazing, investments that pharmaceutical companies make, world-class scientists doing all sorts of work in medicinal chemistry in order to come up with new therapeutics, or come up with new different drugs that they can potentially use to cure different diseases. But we've barely scratched the surface on what's possible out there, and these AI systems are providing new ways to augment this. Stitch Fix is another company you hear me talk a lot about. And Stitch Fix is an incredibly interesting company because, again, from the time it was born, they've woven in these algorithms and AI in order to manage how they interact with customers. But what's really interesting about that is when they're actually coming up, this is a company that does clothing. It's a clothing subscription model. But now it's not just using algorithms to understand what the customer may want in terms of preferences and anticipating those needs, but they're also coming up with new designs for clothing, right? So something that you would typically think would be in the purview of humans solely. And what's really interesting about Stitch Fix is you see down in the bottom left-hand corner is they use machines and these genetic algorithms along with human designers together. They work together to produce recommendations for customers. And so they're using the talents of both, so to speak, to augment the role of human designers in order to figure out what that person is going to like. And so Stitch Fix, again, an incredibly successful company, generating over $1 billion in revenue now, and it's from the ground up. It was born as an AI company, but it's using that to kind of change the entire fashion industry and change the way that we not just shop for clothes, but the way that clothes are designed. And so in the reading itself in the reports, it talks about still some barriers to AI adoption. And we've talked about these the last 2 weeks. And partly why I want to show this to you here is to show that one of the major challenges is attracting, acquiring, developing the right AI talent. But that's not just people that can design algorithms. As the reading also talks about, it's understanding how to match that with people that have deep business knowledge and deep domain expertise in order to link the two together, right? So this augmentation model we've talked about is exactly one of the major barriers that that companies are facing. And so this becomes an incredibly important thing for us to consider as, again, you're mapping out your pathway here for your future career, is thinking through where you can incorporate AI, because it will give you a real advantage. It'd be a very valuable asset to companies, or maybe potentially designing and building your own company as a way to provide unique solutions. Because again, there's a real shortage of incredible talent here. And there's other things like competing investment priorities, certainly security, concerns, some limitations of technological capabilities. And another important one is unclear or no business case for AI applications. That's another thing we want to tackle, is again understanding how some of these tools, these algorithms, these platforms enable us to come up with new strategic sets of choices for our organizations. So within that, right, there's this huge need for AI strategy. And what you see overall here is that 60% of companies that have been surveyed by within this report noted that there's a they are developing strategy and it's an urgent need for the organization. But you see clear differences between these passives to the pioneers, right? So pioneers, right, almost 85 out of 100 of these companies find developing a strategy to be an urgent need, and 90% of those pioneers have a strategy for it now. And so the goal for us is, again, as we sort of consider how AI influences major choices that we may make, this is a critical part of where I think we can build some toolkits, again, to be incredibly important within our organizations, assets in our organizations, by helping make better and more informed strategic choices. And so I love this quote from, this is the person, the woman who runs the analytics group at Pfizer, right? And she notes that these great project-starved analytics experts sit down with colleagues who have deep business domain experience, and good data is brought into the equation that they can review together, right? So this augmentation model, right, the linking of the human side of strategy with the AI side of strategy, is really kind of the powerful combination that allows us to create sort of the organization of the future. And companies like Pfizer and others are making huge investments in developing talent and the capacity and the infrastructures to do this. And so again, the vision behind what we're tackling is this augmented strategist. And I want to return to this quote we saw last week from this Deloitte report, where it talks about the advent of AI makes it possible, indeed desirable, to reconceptualize work, not as a set of discrete tasks laid end-to-end in a predefined process, but as collaborative problem-solving efforts where humans define the problems, machines help find the solutions, and humans verify the acceptability of those solutions. And again, we've seen that now in a couple different cases within our discussion here about how the sort of machine intelligence, right? These generative adversarial networks, or these deep learning systems, provide unique solutions, things we've never thought about, things that could defy 1,000 years of conventional thinking about how you might approach a particular decision problem. And if we learn to incorporate those within our decision-making apparatus to complement the abilities of human actors, I think we find ourselves on the right footing in order to make an effective set of strategic choices in the new era in which we're entering.